Ever look up at the night sky and just, I don't know, get that feeling like, are we really all there is? With all those stars, all those galaxies, it seems kind of crazy to think we're completely alone.
It's a pretty fundamental question, isn't it? Where is everybody? It combines astronomy, biology, philosophy.
Exactly. And that brings us to today's deep dive, the Fermi Paradox. Yeah. It's this mind-bending puzzle about why, in a universe that seems so vast and full of potential for life, we haven't found a single shred of evidence for alien civilizations.
No radio signals, no megastructures, no cosmic postcards, nothing.
Right. So to tackle this cosmic conundrum, we're going to be exploring a conversation between physicist and economist Robin Hanson and Kurt J. Mungle.
Their discussion is titled, Where Are the Aliens? The Great Filter and the Fermi Paradox.
Yeah, it's a pretty dense conversation, but we're going to try to pull out the most interesting bits, especially Hanson's idea of the Great Filter.
The Great Filter is basically his attempt to explain why we haven't encountered any other intelligent life.
Yeah, it's like what's stopping everyone else from getting to the point where they can build spaceships and send out signals and, join the Galactic Club.
Hanson's argument is that there's a series of extremely difficult evolutionary steps, these filters, that life has to pass through to reach that level of advancement.
Like hurdles in a cosmic obstacle course.
Yeah, exactly. And each of these filters is so improbable that it significantly reduces the chances of life making it all the way.
So what are some of these filters they talk about in the article?
Well, the first one is the most basic, the origin of life itself. Like, how do you go from a bunch of random chemicals to self-replicating organisms?
That's got to be a pretty high bar to clear.
Right. Then you've got the evolution of complex multicellular life, which is another huge leap. And after that, the emergence of intelligence, then the development of advanced technology.
Like the ability to communicate across interstellar distances or travel between stars.
Exactly. And finally, the actual drive and capacity to expand beyond their home planetary systems and colonize other worlds.
So basically, a whole lot can go wrong along the way.
Yeah, and the eerie silence we're experiencing suggests that somewhere along that line, most civilizations just don't make it.
So where is this bottleneck? Where's the great filter?
That's the million-dollar question, and it has huge implications for our own future.
Like, if the filter is behind us, if we've already passed the most difficult steps.
Then that's actually surprisingly good news.
Really?
Why? Because it means we're incredibly rare. We've somehow managed to overcome these incredibly improbable hurdles, while countless other potential civilizations haven't.
We're like the cosmic lottery winners.
Exactly. It would suggest that the future could be incredibly bright for us, full of potential for exploration and expansion.
But what if the great filter is ahead of us? What if the hardest part is yet to come?
That's the darker side of the coin. It would mean that the silence we're hearing isn't a sign of our uniqueness, but a warning.
A warning that there's some kind of unavoidable catastrophe waiting for us down the line.
Yeah, something that might wipe out advanced civilizations before they can really make their mark on the galaxy.
And the article even talks about some potential future filters, right?
Yeah, like AI going rogue, global nuclear war, or some kind of irreversible ecological disaster.
Like self-inflicted extinction events.
Exactly. And it reframes the Fermi paradox in a pretty stark way. It's not just about where the aliens are, but how much of the great filter have we already passed.
Yeah, that's a pretty sobering thought.
It forces us to think about our current trajectory. Are we on a sustainable path, or are we unwittingly marching towards our own self-destruction?
Okay, so that's the great filter. But Hansen also talks about another idea called the Grabby Aliens theory.
Yeah, this one's a bit more out there.
The name itself sounds kind of ominous.
Yeah, grabby isn't exactly a comforting word when you're talking about alien civilizations.
So what's the basic idea?
It basically assumes that once a civilization reaches a certain level of technological sophistication, they become inherently expansionist.
Like, they can't resist the urge to colonize every planet they can reach.
Exactly. They spread out rapidly, maybe even at a significant fraction of the speed of light, gobbling up resources and expanding their territory.
So why haven't we seen any evidence of these grabby aliens?
Well, the theory suggests that we wouldn't see them until they were practically on our doorstep. If they had emerged in our observable past, they would have already reached us.
So we might just be in a quiet corner of the galaxy that hasn't been colonized yet?
Yeah.
Like an untouched pocket.
Yeah, that's the implication. But the key takeaway is that this period of isolation might not last forever. Eventually, one of these rapidly expanding civilizations could come knocking.
That's a pretty chilling thought.
It is. It suggests that we might not have as much time as we think to figure things out.
Okay, so we've got the Great Filter and Grabby Aliens, both pretty heavy stuff. But the article also touches on something a little closer to home, UFOs.
Ah, yes. The perennial mystery of unidentified flying objects.
Hanson applies his analytical approach to this topic too, using something called Bayesian reasoning to evaluate the likelihood of UFOs being extraterrestrial.
Right. Bayesian reasoning is a way of updating your beliefs about something based on new evidence.
So, like, how does that apply to UFOs?
Well, first you have to consider the prior probability. That's basically your initial estimate of the likelihood that UFOs are alien before considering any specific evidence.
So just based on the sheer size of the universe and the possibility of other intelligent life.
Exactly. And then you have the likelihood, which is how well the actual evidence supports the alien hypothesis.
Like eyewitness accounts, radar data, videos, that kind of stuff.
Yeah. And you combine those two things, the prior probability and the likelihood to get a revised probability.
Okay, so what does Hanson think about the prior probability of UFOs being alien?
Surprisingly, he gives it a non-negligible probability, somewhere between 1 in 10,000 and 1 in 1,000.
Wow, that's higher than I would have guessed.
Yeah, it's not a high probability, but it's not zero either.
So even a super rational thinker like Hanson sees some possibility there. But then they get into the really weird behavior of UFOs, assuming they are alien craft.
Right. There are three main puzzles that Hansen highlights.
Okay, lay 'em on me.
The first is why we're seeing them here on Earth, but there's no obvious evidence of them colonizing or mining resources elsewhere in the solar system or nearby star systems.
Yeah, if they can get here, you'd think they'd be all over the place.
Exactly. The second puzzle is their motive. What are they doing here? What could we possibly have that they want?
Right, it seems like a pretty long trip just to come and, I don't know, mess with a few cows.
And the third puzzle is their ambiguous visibility. They're not perfectly hidden, but they're not exactly making themselves known either.
They're like just visible enough to keep us guessing.
Exactly. And Hansen argues that this intentional ambiguity is really hard to explain without some very specific and currently unknown theory about their motivations.
It's like they're trying to be mysterious.
Which, if you think about it, is a pretty strange strategy for a civilization that's supposedly so advanced.
It is. Okay, so we've covered a lot of ground here.
Hmm.
The Great Filter, Grabby Aliens, UFOs, it all kind of boils down to this. What's our place in the universe?
That's the big question, isn't it?
And the Great Filter, as the article points out, has huge philosophical implications. If we're truly alone, because we've already passed this super restrictive filter, then our existence is even more precious.
It would mean that we have a unique responsibility to preserve and advance our civilization.
But if the filter is still ahead of us, then it's a warning that we might be on a path to self-destruction.
It highlights the fragility of our progress and the importance of identifying and addressing potential existential threats.
So this whole deep dive into the Fermi Paradox really makes you think about where we fit into the cosmic scheme of things.
It underscores the importance of scientific inquiry, critical thinking, and being open to the possibility that we might not be alone in the universe.
So let's do a quick recap. We explored the Great Filter, which suggests that there are a series of improbable hurdles that life has to clear to reach a high level of technological advancement.
We also looked at the Grabby Aliens model, which posits that advanced civilizations might be inherently expansionist, but we just haven't encountered them yet because they haven't reached our part of the galaxy.
And then we touched on Hanson's Bayesian analysis of UFOs, which suggests that there's a small but non-zero chance that some of these unexplained phenomena might be extraterrestrial.
Ultimately, the Fermi Paradox remains a mystery, but it's a mystery that pushes us to think deeply about the nature of life, intelligence, and our place in the cosmos.
It's a reminder that we still have so much to learn about the universe and our role within it.
And that exploration, that quest for knowledge, is perhaps the most important endeavor we can undertake as a species.
So, here's something to ponder as we wrap up. If advanced civilizations are out there, and they're expanding rapidly, but staying hidden until they're practically on our doorstep, what kind of signs or preparations might we see in the future? And what does the current lack of clear evidence tell us about how life and intelligence might evolve on a cosmic scale? It's a lot to think about, but hopefully this deep dive has given you some food for thought. Thanks for joining us.
Thanks for listening.